Today, we are starting the last section of Chapter 8. Actually, we already started it. We're finishing it. We did Section 8.6, the first part of it, which was solving rational equations. And today, we're doing solving rational inequalities. I do admit that solving rational inequalities is a lot more time-consuming. It's not as fun as solving rational equations. Let's jump right in. Here's an example, and here are the steps, the notes that you guys need to copy down right now. To solve a rational inequality, well, first you pretend that it's an equation. Solve it like if it were an equation. You have some fractions, you want to get rid of fractions. You can multiply everything by the LCD to get rid of all of them at the same time, or you could get rid of one fraction at a time by multiplying by the denominator of the fraction that you want to get rid of. So if you wanted to get rid of the fraction 3 over 2x, multiply by 2x, cancels out, multiply by 2x, multiply by 2x. You solve it like if it were an equation, you get an answer. And then step 2, this is where it gets a little weird. You go to the denominators and set them equal to 0. Now, of course, you're not going to do that with 10 because we know that 10 is not equal to 0. That's impossible. But you are going to do it to the 2x. 2x equals 0, 5x equals 0, and then you're going to solve both of those, right? So you have your answer from pretending it's an equation and solving. You're going to have more answers by setting your denominators equal to 0. And the final step is to plot those answers on a number line and then test areas. Because solving an inequality, we know that when you solve an inequality, your answer is an area of answers, right? Even if it's like x is less than 5, you're talking about an area of answers that are all less than 5. It's to the left of 5. Anyway, I want to pause it, copy down those steps, and we're going to work on this problem right now together. Let's move on. Here we go. I want to move these steps to the side, and I want to apply the steps right now on this inequality. Step 1, pretend it's an equation, right? I'm just going to pretend that this is an equal sign. I want to get rid of fractions. I could get rid of all fractions at the same time by multiplying everything by the LCD. All I got to do is think, what is the LCD? Or I could get rid of one fraction at a time by multiplying everything by the denominator of that fraction that I want to get rid of. So what would you guys like to do? Get rid of all of them at the same time with the LCD, or get rid of one of them at a time?
All of them.
All of them? Okay, so we haven't really done LCD much, but when you think about the 5, the x, the 10, the 2, and the x, the lowest common denominator will be 10x. So the LCD is 10x. So if I multiply everything by 10x times 10x times 10x, all three fractions will cancel out. You could, if you want, multiply 4x or 4 times 10x, giving you a 40x, and then 40x divided by 5x, that will be just a regular 8. Or instead of multiplying, you could cancel first and then multiply. Let me show you how that would work. The 10 and the 5, 10 divided by 5 is 2, and the x and the x, those cancel out. So what do I have left? I have 4 times 2, which is 8. It's the same answer, just a different way of looking at it. Again, you could cancel the 10 with the 10. That's going to disappear. And you're going to have 1 times x left over, which is going to be a 1x. So plus 1x. Or just x. You don't need the 1. And we do have, we're pretending that it's an equal sign, even though it's a less than. And then over here, the x and the x, that'll cancel out. And the 10 and the 2, that'll cancel out. I have a 5 left over. So what are you going to have left on the right side? 3 times 5 is 15. Final step will be to subtract 8. Subtract 8. Answer is x equals 7. Okay, so we got one answer to the inequality. If you read your notes, step 2 is to go back and set your denominators equal to 0 and solve. So it'd be ridiculous to say 10 equals 0 because 10 does not equal 0. But you could set 5x equal to 0. 5x equal to 0. And if you solve it, you're going to divide both sides by 5, giving you an answer x equals 0. Over here, same deal. 2x. If you set that equal to 0, you're also going to get x equals 0. That was step 2. Step 3 is to go to a number line and to plot those answers in that number line. So we have 0 and we have 7. Okay. We need to test the areas to see where our answers are at. Maybe the answer is only on the left side of 0. That would give you the answer x is less than 0. Maybe the answers are on the right side of 0, which would be x is greater than 0. Maybe the answers are between 0 and 7, right here, which would be a compound inequality. 0 is less than x is less than 7. Or maybe they're over here, x is greater than 7. We need to find out by testing areas. So how do you test an area? You just simply pick a number that's on the left side of 0. Give me a number that's on the left side of 0. -2 or even -1, right? Whatever you like. -2 works. Let's work with -2. So here's -2. I'm going to test by plugging in -2 right where my x's are at. So check this out. When I plug in a -2 right there, it's going to be -10 on the bottom. It's going to be 4 over -10. So think about that. That is -4/10. Okay? This guy is -4/10. When I plug in a -2 right there, it'll give us a -4/10. It does say +1/10 though. So let's write that down as well. +1/10. And it should be less than 3 over 2 times -2. When I go 2 times -2, that'll be a -4. So it's really going to be a less than 3 over -4. 3 over -4. Are you with me? Now, you could, this worked out pretty nicely because he told me to plug in -2. I got a common denominator, so I could do this already in my head. This will give me a -3/10. And is it less than -3/4? That is the question. You could use a calculator and go -3 divided by 10. That'll give you a -0.3. And you could do this with the calculator, and that'll be a -0.75. So is -0.3 less than -0.75? If you think about the number line, which one's closer to the positive numbers? Which one's on the right side? The -0.3 is closer to the positive numbers, which means that this one's greater. The -0.75 is further left, which means that this one's less. So this right here is a false statement. Doesn't work. So this number, -2, it did not work. I'm going to say no. I'm going to put an X on it. It did not work, right? So now let's test a value that's between 0 and 7. Anybody? 2. That's a great choice. Let's plug in a 2 right there. When I plug in a 2 right here, it'll be 4 over 10, because 5 times 2 is 10. 4 over 10 plus 1 over 10. What is 4/10 plus 1/10? That's a common denominator already. 4/10 plus 1/10? 5/10, which is 1/2, right? So I really have 1/2 less than 3 over 2 times, and you know what, let me write this down so we don't get confused. 1/2 is less than, plugging in a 2 right here, it's going to be a 4, 3/4, right? So 1/2 is less than 3/4. What do you think of that? Is 1/2 less than 3/4? Yes, it is. So this guy is a yes. It works. The number 2 works. So far my answers are not on the left side of 0. They're on the right side of 0. I just need to check over here also. If over here is a yes also, then I could say that my final answer is 0, or actually x is greater than 0 if both of them are yeses. But if only this one works, then it's going to be a compound inequality between 0 and 7. So let's test the value on the right side of 7. Give me a number to plug in that's over here on the right side of 7. 8, okay. So I could plug in an 8 right there. 5 times 8, 40. 4 over 40. 4 over 40 reduces down to 1/10, right? You could also do this on a calculator. And then plus another 1/10, right? Plus another 1/10. It should be less than 3 over 2 times 8, which is 16. So it should be less than 3 over 16. So 1/10 plus 1/10, that's 2/10. As a decimal, that's 0.2. And that should be less than 3/16. 3/16 with the calculator. 3 divided by 16. I don't know what that is. 3 divided by 16. Change that to a decimal. It's 0.1875. 0.187, whatever. But the bottom line is 0.2 less than 0.1? No, false. So when I test the value of 8, I never put it on my number line, I'm sorry. I tested the value of 8. That is a no. It did not work. So the only place that my answers are at are between 0 and 7. So my final answer to this nasty looking problem is the compound inequality 0 is less than x is less than 7. X's are between 0 and 7. So this is not difficult stuff. It's just time consuming. Dang, it's time consuming, right? Let's do one that's really fun. This one was kind of boring.
Is there like an easier way?
There is no easier way. I apologize. But if you understand this one, man, you could do any question on this section, all right? Copy it down. Step 1, pretend it's an equation, just get an answer. Step 2, go back to your denominator, set it equal to 0, get another answer. Step 3, plot your answers, test areas, decide whether you have a compound inequality, a single inequality, or maybe both a compound and a single. Anyway, step 1, pretend it's an equation. How do I get rid of fractions here? Multiply? By what? Which fraction do you want to get rid of first?
1 over x minus 2.
You want to get rid of the 1 over x minus 2. So I want to multiply everything by x minus 2. Everything by x minus 2. Everything by x minus 2. Okay? Now, it works out beautifully right here because it cancels out. And you'll end up with a minus 1 left over. But over here, the x minus 2 and the 3 don't cancel out. So you need to distribute. X times x is x squared. X times negative 2 is negative 2x. And of course, it's still over 3. It's still a fraction. Again, we are pretending that it's an equation. I mean, you could put the less than, but I'm going to just put an equal sign right there. Now, over here, it's a little more challenging on the right side because you have an x plus 1. That's technically a binomial. So I need to distribute x times x. That's x squared. X times negative 2 is negative 2x. Positive 1 times x is a positive 1x. And positive 1 times negative 2 is a negative 2. And of course, when you combine the middle terms, you're going to get the quadratic trinomial x squared minus 1x minus 2. But it's still a fraction over 4. So I still need to get rid of the other 2 fractions. So what should I multiply everything by now? You could do 12 to get rid of both fractions at the same time, or you could get rid of one of them at a time. We did an LCD on the other one. I'm just going to get rid of one of them at a time on this one. Times 3 cancels out. Times 3 times 3. Now notice this 3 and this 4 do not cancel. So what do I need to do? I need to distribute the 3 to that whole quadratic trinomial, to that whole numerator. So when I distribute the 3, I apologize, it's getting ugly. 3 times x squared is 3x squared. 3 times negative 1x is negative 3x. 3 times negative 2 is negative 6, and it's still over 4. You still have the equal sign right here. You still have, or what, negative 1 times 3 is negative 3 right here. And over here we have the x squared minus 2x. So now at this point, I need to get rid of that last final fraction. Yeah, it would have been faster if we would have multiplied everything by 12, the LCD. But anyways, let's get rid of that 4 by multiplying by 4. That way it cancels out, no longer a fraction. Times 4, times 4, times 4, everything by 4. So what we have left here is a 4x squared minus 8x minus 12 equals 3x squared minus 3x minus 6. Woo, fun stuff. You love it, right? This is a huge equation. Because I see an x squared, I know it's a quadratic, and I know I want to set it equal to 0 to be able to factor, split, and solve. So I want to move everything to one side so it's equal to 0. If I didn't have a quadratic, I would just get x by itself on one side and I would be done. But I do have a quadratic, so let me move everything to one side. Check it out. I'm going to move the 3x squared by subtracting it. Cancels out. What you do to one side, do to the other. Subtract 3x squared. What do we have left? We have a single x squared on the left side. I'm going to do all 3 steps from that one long equation. So instead of a negative 3x, I'm going to go plus 3x, and I'll end up with a negative 5x. And last but not least, I am going to add 6. It's going to cancel, add 6. Negative 12 plus 6, that is a negative 6. This is a quadratic trinomial equation that is now set equal to 0. And that is a great thing because I could now factor, split, and solve. So if I were to think what times what is my c value, the negative 6, that if I combine together is my b value, negative 5, I'll be able to plop it right here into my factored form, and it'll be factored. So what times what is negative 6 that if I combine together is negative 5? Positive 1 times negative 6. Perfect. And now because of zero product property, I will be able to split them. X plus 1, that could be equal to 0. X minus 6, that could also be equal to 0, giving me my two answers, x equals negative 1 and also x equals positive 6. Are you with me? Yay? Más o menos? Okay, that was a fun one. Now, that's barely step 1. Yeah. Because step 1 was pretend it's an equation and get your answers. We just did that. What is step 2? You got to go back to your denominators. If you have any variables in there, you got to set those equal to 0. So look at this denominator. It's an x minus 2, right? So I need to set that equal to 0. X minus 2, set that equal to 0 and solve it. Plus 2 plus 2, you're going to get an answer x equals 2. Right? So now we have three answers, negative 1, positive 6, and positive 2. And we need to do step 3, which is plotting it on a number line and then testing your areas to see where your answers are at. So let's do that. I'm going to, maybe I should do this, sorry, running out of space here. So here's my number line. That's ugly. We have a 6, we have a 2, and we have a negative 1, okay? So we need to test areas. What value would be on the left side of negative 1? Give me a number. Yeah, on the left side of negative 1. Negative 4. Okay. We could use any numbers we want, right? So negative 4, why not? Well, think about, you got to plug it in here, right? So what would be nice to plug in right here? A negative what? Negative 3 would be nice, because then that would get rid of the fraction. So how about that? Let's test negative 3. Now let's see if it works. So negative 3 over 3, that's negative 1. When you plug in a negative 3 right here, negative 3 take away 2 is negative 5. So I really have a negative 1 take away negative 1/5. So negative 3 over 3 take away 1 over negative 3 minus 2. That's really a negative 1 take away a negative 1/5, which is really negative 1 plus 1/5. On the calculator, you could do that, negative 1 plus 1/5, and that will be negative 4/5. Now that has to be less than, plugging in negative 3 right here, that'd be a negative 2 over 4, which is negative half. So that should be less than negative half. So is negative 4/5 less than negative half? Yes, because it's further away from the positives, right? Negative half is closer to the positives. So this is a true statement. So this guy, this negative 3, that's a yes, it worked. So that means that your answers could be over here, right? So if this is the only area that works, I'm going to say that my answer is x equals negative 1. But maybe this one doesn't work and over here it does, or maybe over here it does. So it all depends where your areas work or don't work. So give me a number between negative 1 and 2 that we could use to plug in. 1? Okay. 1 will work. Sure. Hey, but you know what? 0 would work even nicer, right? Because 0 divided by 3 is 0. That'll get rid of it. But then 1 would also get rid of that one. I don't know. Let's use 0. Why not? No, you said 1. Let's use 1. So I want to test the number 1. So when I test 1, that's going to be a 1/3. 1 minus 2 is negative 1. 1 over negative 1 is negative 1, but with the negative in front of that negative 1, it's going to be a positive. So you really have 1/3 plus 1. 1/3 plus 1. And that should be less than, plugging in a 1 right there, that would be a 1 plus 1 is 2. 2 over 4 is 1/2. So that should be a less than 1/2. So is 1 and 1/3 less than half? Let me repeat that. Is 1 and 1/3 less than half? Is 1.33333 less than 0.5? No, it's not. So that's false. So on our number line, we're going to put a no right there. So the answers are definitely not between negative 1 and 2. Give me another value that's between 2 and 6. 3, okay. Let's plug in a 3 then. You can plug in any numbers you want. I am plugging in a 3 this time because you told me to. So if I plug in a 3, that's going to work out beautifully actually. 3 right there, 3 over 3, 1. 3 take away 2 is 1. 1 over 1 is 1. So you really have 1 take away 1. Beautiful, that's 0, right? This whole side is 0. Is less than 3 plus 1 is 4 over 4, that's 1. 0 is less than 1. True or false? True. So I did that all in my head because you guys gave me the beautiful number to plug in 3. And that is a true statement. So this is a yes right here. Okay. Now let's find out any value over here on the right side of 6. Anybody? 8? 9? Okay, 9 sounds good. So I want to test 9. 9 divided by 3 is 3. So I have 3 minus, let me actually write that out so I don't forget. 3 minus, then I have 1 over 9 minus 2. That's 1 over 7. So 3 minus 1 over 7, that should be less than, plugging in a 9 right here, 10 over 4. 10 over 4 reduces down to 5 over 2. So the question is, what is 3 take away 1/7? And you could use a calculator. 3 take away 1 over 7 equals 20 over 7. Change to a decimal. That'll be the value 2.8571. Question is that less than 5 halves? What's half of $5? Is $2.50. So is 2.8 less than 2.5? No, it's not. So the 9 is a no. It did not work. That means that none of these answers over here are going to work. So where are our answers actually at? They are on the left side of -1, and they're between 2 and 6. So between 2 and 6, that's a compound inequality plus the single inequality. So we are done. All we got to do is show our inequalities that represent those areas. You're going to write x is less than -1. That's one answer. Then you're going to use the word or because there's another answer, the compound inequality, x values between 2 and 6 with less than symbols. So there's the other one. But you have to put both on your answer in order to get full credit. So this was fun. I hope we understand that. Look at all that beautiful work. So if you understand that, you're going to understand any question on this section. If we go to the actual homework, the only ones that were inequalities yesterday, we were supposed to do all the equation ones, the ones with equal signs, and only the even ones, 2, 4, 6, 8. I think we skipped 10 and 12. Oh yeah, skipping 10 and 12 because 10 are inequalities. So do 10, do 11, do 12, and 13 is also an inequality. And you'll see that these are way easier than the crazy one that we just did. Again, treat it like if it were an equation. How are you going to solve this? Multiply everything by y. Solve for y, get an answer, plot it on a number line. Go back to your denominator, set that equal to 0. That's going to be another answer, y equals 0. Plot that on the number line. Test your areas, and you'll be able to get your answers. Okay? So I'm going to give you the rest of the class to work on this homework assignment, the ones with inequalities, 10, 11, 12, and 13. If you haven't finished the other ones from yesterday, please do that as well. That's all to Chapter 8.